Previously, we have seen how to use this lean tool in 6 simple steps. And let's see this, how we can use the SMED method to reduce the time for preventive maintenance. Let's see an example of heating furnace in which we are performing preventive maintenance once per week, and it's taking more than 5 hours every week. And let's see how this method can help us to reduce the overall maintenance time there. The very first step is to record all the activities being performed during this preventive maintenance. So there are two methods. First is that we go in the production and we note down all the activities being done. The second method is to do the video recording, which makes every process, which makes every step in this analysis very easy and very effective. So wherever it is possible, wherever it is allowed by the company and the management, we must try to do as much as possible the video record, because that helps enormously later on to discuss with the whole team, to show the video and to ask the questions how we can externalize this activity, how we can do this much more quicker. All analysis become much more easier through the video recording if it is allowed. So in this our example, we went in the production when the preventive maintenance was being performed, and we did the video recording of the main activities, and we have here a list of 12 activities. And so with this we have the column from to the start time of an activities and end time of the activities, and after that in the last column we have here the total time spent. For example, the activity number 2, it took us 1 hour, activity number 3 took 20 minutes. So this is the beginning of the analysis. Let's go through very quickly these 12 main activities. The furnace is being stopped, the activity number 1. Activity number 2, we are waiting the oil of the furnace to be cooled down so that it comes to the room temperature. Activity number 3 is then the maintenance guy is collecting the activity number 4 is that we are pumping out this tempering oil out of the furnace. Activity number 5 is we are filtering that oil. Activity number 6 is that we clean the filters and we inspect the moving parts for any wear and tear. The activity number 7 is that we are cleaning the furnace tab. Activity 8, we fill that filtered oil back into the furnace. Activity 9, we heat up the oil again. Activity 10, we produce the first 10 parts. Activity 11 is we bring these parts to the quality department and wait for the results. And once this is okay from quality side, they say we can run the machine. Then activity number 12 is that we start the machine. If we now apply our SMED method, which we have previously discussed, the first step would be to clearly define which activity is external activity and which activity is the internal activities. So here we see the activity number 3 as well as the activity number 11 are the external activities. In step number 2, we are aiming to externalize all the external activities. So we see here, we have here activity number 3 in which the maintenance guy is bringing all his equipment, pump container, etc. Altogether, it is taking us 20 minutes to perform that, and he can do that. And he can do this before the machine has been stopped or during the activity number 2 when the machine is being cooled down. Similarly, the activity number 11 is that we are waiting for the quality department to give us the results. And instead of waiting during the activity number 10, we can take the 10 parts out for the inspection, and after that we can start the machine immediately. For this, we really have to do the risk analysis. How often we have seen in last 1 year that the first 10 produced parts were defective. If that has happened, say 2 times in the whole year, so if we run the machine for this 25 minutes, how many parts we will be producing? Imagine we are producing 25 parts here. So if this has happened 2 times in previous year, so it means we could have wasted here 50 parts. The cost of 50 parts we should compare with the cost of the not running machine for 25 minutes every single week in the whole year. So with this argument, in my experience, all the time I have done this analysis, the cost of stopping the machine was always much more higher than in case we have the quality issue and we have to scrap these parts few times per year. So with that, we can keep the machine running and do the inspection when the machine is running there. After that, the step number 3, we have seen that it is to convert the internal activities into external activities. So here we can see the activity number 6 was to clean the filter and check the moving parts for wear and tear. So how we can externalize? So instead of cleaning these filters when the machine is being stopped, we can simply replace these filters with already clean filters, another set of filters we can simply replace. So we will be much more quicker, and the cleaning of the filters can be done offline when the machine is running. Another activities we are performing here is we are checking the moving parts. So we are unscrewing the cover, metallic cover here, and then we are checking if the parts are okay, and then we are screwing again the cover. So we can ask the team how we can externalize, how we can do this activity quicker. One example could be that we would have a transparent cover in which we need not to unscrew the parts, and we can just see anytime that the moving parts are in good shape. We have externalized this activity completely because we need not to stop the machine for doing this activity. So by doing this we can save our time. For example, activity number 6 took us before 20 minutes. Now we can replace the filters, and inspection we can do anytime of the moving parts. So we have finished this activity in just 5 minutes. Step number 5 is to improve the internal activities or to eliminate them completely. Here the activity number 2 is to cool down the furnace oil. It is taking 1 hour. So if we use an external equipment for cooling, we can accelerate the cooling here and we can reduce the time. The activity number 4 is pumping out the tempering oil out of the furnace. So here, if we have seen that it is taking us approximately 40 minutes. So instead of pumping out the oil with one filter, we can ask if we want to make it quicker, how we can do it. Maybe we can use 2 pumps instead of 1 pump, and we will reduce the pumping time by 50 minutes. Or we can use one bigger pump, which is much more quicker. The activity number 5 is to filtering the furnace oil. So here we are taking the oil out, bringing the oil to filtering unit, and after that we are filtering there separately. One option could be that when we were previously pumping out the oil, during that process we can have the filtration unit mounted on the pump. So during we are taking the oil out of the machine, the filtration is also happening simultaneously at the same time. So with that we can eliminate the filtering time completely. Activity number 7 is that we are cleaning the tub. During the preventive maintenance, it was being done manually. One person was manually doing the whole cleaning and everything. We can ask how we can do this cleaning in much shorter time. One idea would be that we use the equipment. For example, we can use the water jet or any other equipment which is cleaning everything in much shorter time. Another idea would be that instead of one operator, there are 2 operators who are doing all the activities. For example, one operator would be the machine operator, and another worker would be from the maintenance department. So the whole maintenance, including this cleaning, can be done by 2 workers instead of 1 worker. So with this arrangement, we are also shortening a lot of maintenance and downtime of the machine. The activity number 9 is again heating up. Similarly, as we have cooled down our oil with the help of external unit to reduce the time, in the same way we can use an external unit to heat up the temperature so that we are bringing it to working temperature, the oil, in much more shorter time. So here we see with that we can further reduce the time required for these internal activities. So here we can see that we have reduced the time here by 40% as compared to the time it was in step number 3. We know the step number 5 was to improve the external activities. We see the example number 3, bringing the maintenance equipment, tool and pump, in which the maintenance guy was collecting all the things. So if he's doing it offline now, but still he's spending 20 minutes to collect all the things from different corners and everything. But if we would have one maintenance trolley for this maintenance particularly, he need not to collect from different areas and different equipments, but he would have always one trolley ready where everything is there and he's just bringing. So he can save his time also for collecting different equipment from different areas. Similarly, the activity number 11. Though we have externalized this activity, now this is done when the machine is running, but still the time spent by our operator is still the 25 minutes. We can reduce his effort, which is the aim of this step to improve the external activity. If we train the worker to do the whole inspection, so that we need not to go far away to the quality department, wait for the result and then go back again there and bring the parts back, we can eliminate all these things if we train him and if we place the equipment for the measurement or microscope near the furnace, so that he need not to go there. He has the training, he fills the form, protocol, everything, whatever the quality department is doing, he can do that himself. This is how we can reduce his work. In SMED method, we know during this step number 6, we eliminate the setup time through the design change. In this example, we have used the SMED method for preventive maintenance. So here this means that how we can reduce the frequency of the preventive maintenance. We are doing at the moment after every week, because the oil is being dirty, the cables are breaking, and we have wear and tear of the moving parts, and we need to do that every week. Instead of doing it every week, in this step number 6, we can ask what we can change, what design changes we can do, that we don't have to do the preventive maintenance after 1 week, but maybe in 2 weeks or maybe in 3 weeks. For example, we know that we have to do the preventive maintenance because the oil gets dirty after 1 week. But if we could do pre-wash of the parts with any inexpensive process, we can very easily increase the time the oil gets dirty. And we can also use a better filtration method, maybe better filters or other filtration unit, that the oil gets purified and it can stay in good condition for more than 1 week, for 1.5 weeks or 2 weeks. And also we can check for a better quality of oil. If we know that every week we have to do the preventive maintenance because the cables are getting broken, we can ask if we have alternative supplier of cables, and the mechanical parts which are getting damaged, we can check if we can have better quality of the parts. So with all these things, if we discuss in the team, we can definitely come up with the ideas that we can reduce the frequency of preventive maintenance. In the end here, we can see the result that in every step we could reduce the preventive maintenance time. For example, in step 2, we could reduce 13%. Step number 3, we could reduce 4% further. In step number 4, we have further reduced the preventive maintenance time 40%. In step number 6, we can reduce this to 11%. So in total, we could reduce the preventive maintenance time by approximately 70% here. So we have seen here that the SMED method is not limited to only setup time optimization. With this example, we have seen that we can optimize the preventive maintenance. We have got the similar result. We have reduced the preventive maintenance time by 70%, which is a very good result in the first implementation. And after a few months, you can again repeat the SMED method and we can further optimize this process.